So we begin our next chapter in Trig. This is chapter 5. I prefer this to the other Trig chapter. This is the very algebraic Trig chapter. It's my favorite. Which should tell you something. We're going to start with Trig identities and swapping and simplifying. And I think most kids find this lesson the most frustrating because sometimes you don't feel like you know when you're done. Like, what does my teacher consider simplified? Is this simplified? Should I go further? Have I gone too far? You know, those kind of questions. So today the rule of thumb is less. If you can make it look like less terms, that would be considered simplifying it. And our approach and our strategies are going to be very algebraic in nature. A lot of instincts are going to be kicking in today. Like, what do you think we should do? Like, there's no magic formula, right? But we have some strategies in our tool belt. And this lesson is really gearing you guys up for what's called manipulation, like algebraic manipulation, or in this case, trigonometric manipulation. This is a skill that's really hard to teach kids because it's just trying to get you guys to be flexible and fluent, which, how do you do that? So you just have to practice a lot. So there's a huge note on your answer key for your homework tonight. It says, like, here's the answers, but you better be showing me a whole bunch of work. I need to see it all right? You get common denominators, I want to see it. You traded something, I want to see it. Ignore this next slide, that's a lie. We're not retesting anything on this next test. It's all going to be new stuff. It's going to be a good time. The other thing you might want to get out, guys, is your blue formula sheet, because that is the same formula sheet that you will be given on your test. I'll give you a fresh copy for your testing, but you just need to know what you're working with, because there's a lot of identities that you aren't given, because they're just manipulations of the ones that you are given. And some of them you just have to flat out memorize. So like, for instance, here, the reciprocal identities. They're not anywhere on your formula sheet. You need to have these memorized, PreCalc students moving on to calculus. Yeah, you need to know those off the top of your head. I understand. Now, you have to know that sine and cosecant are reciprocals to each other. And then, for some reason, this one keeps getting you guys. Yeah. It doesn't even make sense.
Well, I mean, I guess it does. Because
it does.
Yeah.
It kind of does. How? Well, the tangent function, if you think about it right, just let's go to our friend in the first quadrant, right? Boom, boom. If this ordered pair right here, if you think of it like an XY ordered pair, and I say little kid formula, what's tangent to you? Opposite over adjacent. So your opposite leg here is the Y, and your adjacent leg is the X, right? So tangent is Y over X. Well, you guys secretly know that these ordered pairs, these components to the ordered pairs are not X and Y at all. What are they? They're cosine and sine. So this really says sine divided by cosine. So if you really are in that much of a jam, like you've caught on to my dyslexia and it's like catchy or something, you need to be like, whoa, which one is it? Because if you screw up cosine over sine, sine over cosine, you go screwed up a whole bunch probably on that same test. So you need to make sure you nail that one down. Yes.
So if I did mess that up, though,
it would be one concept error, but a big one.
So is that 4?
That's a 3. Yeah, that's a 3. My Algebra 2 students have to know that tangent is sine over cosine, so do you. All right. So the good news is, once you can nail that one down, you got the other one, right? Because if tangent sine over cosine, then cotangent must be the reciprocal of that. You have it somewhere in your brain. All right, a couple other. I'm just gonna quit my life goal because tangent ruined it for me. Does any of this matter? Does matter matter? Let's talk about black holes again. No! All right. So this notation, they get very excited about this. This notation, kids get bamboozled by this the first time they see it. This represents this. They're the same thing, but mathematicians call this the shorthand notation, which to most humans, they're like, that's not any shorter, but it is.
It is because you don't have to put parentheses.
Right. There's no parentheses, which is like a world of, it's like a lifesaver, right? Yeah. So then you get some kids who are like, well, Bruzo, why can't I just write that?
Because that's theta squared.
Yes, this is implying that your theta is being squared, which is not at all what we're trying to talk about here. We're squaring the whole function. So just be aware that we're going to use, you know, the shorthand notation where they stick the squared symbol in between the function and the variable itself. Yes, Daniel?
So how does squaring sine, though, not just square sine and not, how does that square the whole function?
Well, sine, like sin, is an abbreviation for the function for sine. It's like saying I'm squaring the square root symbol. Like you don't. You're squaring the function square root of x minus 3. Like it's sine of theta is the function itself. You can't just choose to square a word.
What if I want?
It would be nonsense.
So
Now,
it's an actual function.
sine is, yes, and you've seen it. It looks like this.
Right.
Right.
But like the word sin doesn't have
No,
just,
that's
like,
that's just an abbreviation for the sine function.
okay.
Yeah.
That's
Gotcha. I know, it's a lot of things to wrap your brain around. We let you guys get away with murder when you're little kids, and I'm guilty of it too. Like today, for instance, you got to catch me on it. When I start trading things, and my brain and my pen are moving at 2 different speeds, right? So I'm like, tangent, sine over cosine. So then I start just writing like sin cos with no variable, which is gibberish, and I need to not do that, which means
Sine and
you
cosine
guys...
of the tangent.
Yeah. So we need to make sure that when I'm writing out functions and I'm trading, that I am being thorough and I'm writing it properly, especially since I'm the teacher. Like if anyone should be doing it right, it should be me. So I get a little like crazy because I love these so much. Like, does that put fear in your heart?
Yeah.
That I love
When
this so
a
much.
teacher says that they
Yeah.
love something,
I know, I gotcha. All right. So this is kind of one of those things where my friends who just think factoring was the bee's knees when you learned it. Yeah, bee's knees, you like that phrase? Those of you who are like, factoring's fun. You're probably going to love this stuff too, because you're right up there with me. Like,
Is
cool.
factoring
On your
fun?
cool level. It's right there with a bruzo.
Like I did enjoy the sine functions. Like that's an even though I did a bad
We enjoy
job.
all of this. Your class is so good, Mrs. Abruzzo. Thank you for teaching us PreCalc at 9 in the morning. Right? Well, good thing you are really good at math. Everything's falling into place. I was born ready.
Are you going to be an astrophysicist? Is that what you're going to do?
I just said that.
I didn't hear that you were whispering.
Daniel is a little hard of hearing
Astrophysics
today.
is fun. We love astrophysics.
Sure we do. All right. So, these three, the big three here, these are on your blue formula sheet. Do you see them? They're probably in their own box. They probably say Pythagorean identities. Can you find them? Locate them on your blue sheet.
There's someone.
They're on there. They're at the top. It says Pythagorean identities. Can't miss them. So, here's the problem. In PreCalc, while I might give you these three, you might not have them in the future. Yeah. Because in Calc, you get nothing. So here, first of all, let's talk about the big guy. Sine squared plus cosine squared equals 1. That is just a derivation of Pythagorean theorem. If you think about one of your angles on the unit circle, we just reminded ourselves about sine and cosine and how they're the x and y values of this triangle. And on the unit circle, the radius is a 1. So if I was to set up Pythagorean theorem, it would look like this. And then 1 squared is silly to write, so we just call it a 1. Now, watch what happens if I take, let me do this in the right order this time. Watch what happens if I take, let's see, this original guy, and I divide every single term by cosine squared. Because that's something you can do in math, right? As long as you divide every term by it, you can divide by whatever you want, as long as it's not 0. Watch this. What's sine squared over cosine squared? Uh-oh, here he goes.
Tangent.
It is, so it's squared, so we'll call it
Squared.
tangent squared. And what about cosine
1.
squared divided by cosine squared? And then what about 1 over cosine squared? Well, 1 over cosine would be secant, so this guy would be secant squared. Oh, looky there. It's
So subtract
it's that guy.
squared. What?
It's this guy.
Oh.
So I took the original one, and I divided everything by cosine squared, and I got this guy. So what do you think would happen if I took the original guy and I divided everything by sine squared?
It's probably going to become.
It's probably the other one. Oh, I hate when you ruin it. All right. So sine squared over sine squared is... hold on. Sine over sine is... Oh, no. Cosine over sine would be cotangent, but it's squared, so it's cotangent squared. And then 1 over sine squared would be cosecant squared, which is this guy. Yeah. Yeah. They put the 1 in the other order, but commutative property. Yes, sir.
I don't really understand where that 1 comes from, though. Like
It's,
the
you're
one
dividing by itself.
to begin. Huh?
Three divided by three
The
is one.
the one up top in the original.
Oh,
yes.
it's the unit circle. Who has a radius of 1. It is a locked value.
Oh.
Okay.
got
I mean, you could expand the unit circle, but the ratio will, because all the legs would be amplified. Like if you put a 3 on there, all the legs would have like a factor of 3 and they'd all cancel out. Okay. So it's the most basic version of all the functions we can come up with. Okay. So, well, we already showed them. Why do I have that? Okay, so this would be nice if I did this for you, but I'm not going to do this for you because you all graduated out of Algebra 2 and you don't need this. Look at this first row, guys.
Skin of my teeth.
By the skin of your... No, I was your teacher. You were fine.
I don't remember.
You did great. Do you notice that horrible box I just made? It's all the same thing. This is the original guy, and this is just someone manipulating it. So like here they subtracted the cosine squared over, and that's another version of it. And then here they subtracted the sine squared over. Now there's other variations of it that involve negative coefficients. We won't talk about those right now. But they did the same thing for the tangent guy and for the cotangent guy. So as long as I give you the basic 3 on a formula sheet, you should be able to manipulate the heck out of it and come up with any trade. All right? Fun. These are going to be great. I can't wait to do more of these with you. Well, that's a lot of things you don't have. We'll move away from that slide. Now, your book tries really hard to make you guys use Pythagorean identities to solve these questions. It's not worth it. The only people it's worth it to are like math team kids who have really horrible problems to do that don't involve numbers. Like if they give you ratios that have partial unknown values, like if they say the sine of theta is like x over 4, like we've had those problems, right? And they want something horrible, then maybe using the identities would make sense. But for like all these questions on your notes here, you should just be living in quadrant plane land like we have been. So look at this clue. Sine of theta is 3 over 5. Theta is between 0 and 90. Find tangent. Well, first of all, tangent and sine don't have a really good direct relationship. So I should just go ahead and draw this. This is an old question. Oh, how do I know I was in the first quadrant? Because it said so, yeah. It said 0 to 90. So this sine is 3 over 5. So I think about how sine could be written as a coordinate plane triangle. And sine would be opposite over the hypotenuse, which means our adjacent side is 4. And now when I ask you for the tangent of this particular angle, y'all going to tell me 3 over 4. That was much quicker than trying to manipulate one of the identities to get the answer. Just trust me on that one. Okay. As a little aside here, this is sometimes the question that they'll say. They'll say like, sine of theta equals 2 over 5. What's the cosine? No, because they're not reciprocals of each other. So this is what your book wants you to do. Ooh, not that. I'm just making up my own identities like Daniel today. All right, so this is what your book wants you to do. It wants you to say, hey, that's a thing, right? The cosine squared plus sine squared equals 1. That's a Pythagorean identity. So if sine is 2 over 5, then you could do this.
4 over 25.
Right. And then what could you do with that 4 over 25?
Subtract it to the 1.
Right.
From the 1.
From the 1, yes.
So now we have 21 over 25.
Right. So the cosine squared is 21 over 25. And then to find cosine, you could square root it. All right. So the cosine would be the square root of 21 over 5 because you'd reduce that. Was that easier than drawing it and doing Pythagorean theorem on your own?
No.
I don't think so. But could you imagine someone with a very atypical question? Like our mathletes get very weird questions on math team question tests, and it'll have variables stuck in the middle or like a relationship that you're supposed to know, and it's really hard to just draw. All right, I digress. Guys, some of these don't involve drawing at all. Some of these just involve your brain. Now, if I told you guys, I've only slept for like 3 hours, so your brain's working better than mine, okay?
Slept for 3 hours?
It's a long story, but I was in the ER with Mister. All right, so cotangent of theta, 12 over 5. What's tangent?
5 over 12.
Yeah. Did I have to draw a triangle to figure that out? No, I'm supposed to know my relationship of the identities, and that was a quick, easy reciprocal identity. So here's, and knowing me, I would have drawn it because I'm like such a suck up. I want to show my teacher that I know how to draw triangles, but that was a waste of time. So sine theta equals -1/4. What's cosecant?
The inverse of sine.
The reciprocal. So yeah, don't say inverse. That's the wrong word, right? Inverse and not reciprocal. Now that we know all about inverses, we can't talk about inverses that way. This is a reciprocal. Well, some of us do. We just tested it again for the second time. Different. Inverse sine, reciprocal of sine are not the same idea. Be careful.
Oh, because inverse is sine with a little -1 at the top.
Yeah.
And that's actually the arc sine.
Right. Which is only defined from?
-90 to 90.
Yeah. According to some of your friends, that's not true.
Or negative pi over 4.
Pi over 2, but yeah. Alright, so same idea here, guys. I could try to use a Pythagorean identity and have fun with that, or I could just draw it. Just for funsies, can y'all tell me what quadrant we'd be in? We would be in the fourth quadrant, yeah. A negative tangent or cotangent and a negative sine would be yonder. Alright, I don't really want to do that question because it's boring. Move on. We already talked about this when we looked at the graphs of sine and cosine.
Can I do that on tests?
Because it's boring. Can you skip it? No. See, I have like a master's degree, so I'm allowed to do that. That's why I went to college, so I could just cross off problems randomly on worksheets.
So they let you do that when you get your master's
Right.
degree in
Yeah,
college?
that's one of the things they let you do once you get your master's degree. You could just cross off worksheet problems. Okay?
I want to get my master's degree.
Do you guys remember which one was even and odd when we talked about sine and cosine? So, you think about sine, looks like this, right? And cosine, oh man, looks like they kind of like that. Do you remember who's even and odd? Sine is, what do you think, Piper? Sine is the blue guy, which has symmetry of the origin, so it's odd. Sine is odd. We saw that in the graph. Yes, ma'am. Yeah, I thought you were trying to answer me. She just doesn't care. Just threw it out there. So cosine, which is the weird horseshoe one. Oh man, I just made that really ugly. Cosine has that y-axis symmetry if you squint, which means it is even. So that's the visual representation for why it's even and odd. Let's talk about algebraically why it's even and odd. The odd test, the algebraic test for something that's odd, is if you take your function and you plug in a negative x value, you get the opposite function out, the opposite output. But for the even functions, if you were to plug in a negative x into an even function, you just get the original one back again. Let me show you a little, this is not on your paper, I don't think, so just look on the slide here. This is a representation for what they're saying. So, we have an ordered pair up here, and it doesn't give you an angle value, I'm just going to make one up. I'm going to say this is at pi over 6. And let's say this guy down here is at negative pi over 6. Well, look at the cosine values. At pi over 6, you get x, and at negative pi over 6, you still get x. So you get the same output back again. And that's why cosine is even. But look at your y values, which we know are sines. If you plug in pi over 6, you get y. And if you plug in negative pi over 6, or you evaluate it at negative pi over 6, you get negative y. And that is the definition for oddness. So that means, I don't know why I keep switching colors on you, I'm sorry. That's why sine is odd. I don't know, let me erase that. That's really confusing. So the reason I bring that up is because now there's a whole nother set of identities that you can use where if you have sine and you're evaluating it at a negative angle, you can say, forget that, I'm going to call it negative sine positive theta. That is a nice obvious trade for us from here on out. Super obvious, right? And then cosine, if you try to trade out cosine of a negative angle, you just get back the original angle again, cosine of theta. So these are really the only two that we're going to be using possibly in the future, and really this doesn't come up again until we go to prove the sum and difference formulas, so you can kind of put that on the back burner of your brain. There might be one homework question, but sum and difference formulas are coming up next week. Maybe.
Sum and difference formula, because that sounds awful.
Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Yeah, exactly.
Trig.
Yeah, a little bit.
I don't remember what it is.
So like you know how the unit circle only has a certain set of angles that it talks about? You know, pi over 6, pi over 4, pi over 3. Well, what if I'm like, what's pi over 12?
Oh, that.
Yeah.
Oh, and then you have, because how do you get pi
Yeah,
over 12?
yeah.
You have to subtract
It's not
angles
bad.
from
I
angles.
promise you guys it won't be bad. I know some of you guys have bad memories of that in Trig, but it'll be fine. Bad memories of Trig. Lots of people take Trig. It's just Trig. Trig is, here's how you take the Trig class and you're like, okay, this is a lot of information for the first time ever. And then you see it again in PreCalc or in Calc and you're like, okay, it's better now. Like you just need it to settle in your brain a little bit. Yes, and some of us haven't had much Trig in a while. Yeah, I got you. So cofunctions, this is another set of identities that we, in theory, could use to trade. Cofunctions, basically, here's what it says. Sine and cosine are cofunctions to each other because of this. If you're in a right triangle, think like baby right triangles when you were little kids. The cosine of this bottom angle is the same as the sine of the other angle. Like, have you ever noticed that relationship? Yeah, most kids don't. But they're called cofunctions for a reason. So these angles are related to each other because they are complements to each other. Like if this is 40 degrees, this is 50 degrees because of the relationship in the triangle. So this is a whole bunch of identities that in theory we could use, but fun fact, we're not going to use them on the homework today. So if you don't mind, I'm just going to skip that example. Okay. We're going to revisit them when we come back to the sum and difference formulas starting, next week sometime. Could you guys flip over? This is where we're actually going to dive in and do some simplifying. And some of it's going to seem obvious, like, yes, that's exactly what I would have done. And some of it's going to be like, what? In 100 years, I would have never thought to do that. And maybe that's true on some of them, but maybe you will think to do it next time, okay? So here's on this slide, these are some ideas of what to do when you're stuck or things that you could try. And number one is the big one. If you're really, really, really stuck and you're like, I just don't see anything, trade everything for a version of sine and cosine. So like tangent gets swapped out for sine over cosine. Secant gets swapped out for 1 over cosine, and see what you can work with there. The problem with these questions is, like we talked about earlier, sometimes you don't know when you're done. You're like, am I simplified? Is this as good as it gets? And sometimes you go too far. I've seen kids do that. Most kids don't go far enough. And the worst thing you can do is just copy the answer key, in which case we will have a chat because these have a lot of work. So I need to see your work. You're going to trade. The Pythagorean identities are going to be your new friend today. You're going to see them pop up a lot. You might need a factor. Trig. Yeah. There's going to be a question coming up today where you're like, what? I would have never thought to do that. Well, now you got to think to do that. Common denominator is a big one. So as we take our notes today, colors are going to be important. You know me and colors. And also taking notes as to what you did. So like when you get a common denominator, put a little note like common denominator so you can follow your work a little better next time. All right. Here goes. This first example, and I think you got like a bunch of horizontal space. You're going to probably want to use it. So start your work way over here. So here's what I'm going to do. I'm looking through this question, and I'm seeing a lot of things that are not sines and cosines. So I'm going to trade them out. For instance, cosecant and cotangent squared are all things that I could trade. And I don't really know what to do right now, so I'm just going to start there. So cosecant, trade that for me, guys. What's another name for cosecant in terms of sines or cosines? 1 over sine. Thank you. That made a lot of sense, Daniel. Thank you. And then cotangent squared. Now, what's cotangent? Let's just start there.
Cotangent is cosine of sine.
So cotangent squared would be cosine squared over sine squared. Yeah. So all I've done so far is I've traded some things. And I know you're like, ooh, sine, 1 over sine, that's cosecant. But that would be trading in the wrong direction. I'm trying to look at everything in terms of sines and cosines right now. I don't know why my handwriting is getting extra bad. It's the sleep, I think. Now, Oh, I do need a squared there. Thank you. Yeah. Good call. That would be bad. Because my pen and brain worked at 2 different speeds. So the thing I just bubbled in blue, I was really hoping to see some cancellation or something. And I don't. I don't see any cross cancellation. So I just have kind of this disgusting fraction. I have cosine squared over sine to the third. Right? Yeah. Sine times sine squared.
Why is it not? No, never mind. We're not right.
Oh, it is.
It is. So, this doesn't feel simplified. Like, there's fractions, there's still an addition problem in it, so I need to travel back to 5th grade. What does my teacher want me to do when I'm trying to add fractions? Common denominators. So I'm going to write a little note to myself. Common denominators, here we go. The common denominator in this question would be sine to the third. So what I'm going to do is I'm going to write down sine to the third down here. This guy has it? What does this guy need? 2 more sines, yeah. It needs a sine squared. Now, I know you're like, oh, I'm not going to show that work. I'm just going to magically do it. No, you're going to show that work on your homework and your test. So show me common denominator. That's you multiplying both the numerator and the denominator by the missing term. Now, notice my answer so far, I went ahead and wrote it as 1 denominator. That's the whole point of getting common denominators, guys. What's in your numerator here? Cosine squared plus sine squared. And my brain's like, I just want to be done because I see what's going to happen. What is cosine squared plus sine squared? Isn't that a Pythagorean trait? It is 1. Yes, this guy right here. That's a 1.
Yeah.
So you have 1 over sine to the third. I mean, that doesn't feel simplified.
That looks exactly simplified.
I know, and some kids would be like, I'm good. Math teachers don't really like that.
You said smaller, and that is small.
Can you think of a way to make this look just a skosh better?
Oh, just
Divide everything by 1?
How about cosec? Ooh, to the third. To the third.
Oh.
Cosecant to the third.
I
Doesn't that look a little prettier?
Yes.
And you know, like potato tomato at this point, guys. None of this looks pretty. Yeah, that makes sense. Makes about as much sense as this. All right, so guys, if you think about everything we did there was a lot of stuff in one problem. So we traded out for sines and cosines. We tried to simplify, didn't have a lot of luck. Got common denominators, did a Pythagorean trade, and then we ended up doing a reciprocal trade right at the end. Whoa, that was fun. And I know fun.
Is that an easy one? Mediocre.
Medium. Yeah, that's a medium. A level medium. Yeah. Yeah. There'll be some hard ones. Now, here's the other fun part of this. You and your neighbor might take totally different approaches to the question and still get to the same place. What?
said such as white it out anymore.
So, the unfortunate part is one of your paths may have been more direct to the answer than someone else's path, which is kind of the trap I fall into sometimes. Sometimes I don't take the most obvious and efficient path, and that's okay. I enjoy a good identities question. Now, tomorrow, we're going to do the verifying identities where they look like proofs, where you know exactly where you're supposed to get. I find those to be a little easier because, like, at least I know when I'm done. The problem is some of you don't show all the work that happens in the old noggin, and that's where you run into trouble. I left my paper at home. It's a test, Daniel. I know. So, anyone have any algebraic or trig or pre-calc instincts on this one?
Divide by cosine.
Oh, that's illegal. You can't divide by, this isn't even an equation. You can't divide by anything. All right, I heard trade tangent. Are you maybe tangent and cotangent while we're at it? All right, I'm with you. What were you going to trade it for? Okay, sine over cosine.
Sounds
Stupid to me. Jeez. And then cosine over sine. Now, I was hoping someone would say that. Can you add those together?
No.
Why?
It's not allowed.
Why?
Because they don't have a common denominator.
They don't have common denominators, so you can't add them together. And then you're like,
we can multiply both sides by each other.
you could. You could
I'm
get...
sorry, okay?
So the suggestion by Daniel, which is a good one, you were going to get common denominators and add them together. We could do that.
Yes, both sides.
Now, I heard some whisperings of some illegal things, like someone was trying to cross off cosines and sines. That's not a thing. This is an addition question. Thank you for not doing that then. Now, first hour, they decided to distribute the cosine.
I don't want to do that.
Potato, tomato again, guys. It doesn't matter. We're going to end in the same spot. So you want to go with Daniel's suggestion of getting common denominators? All right. So this blue thing in the middle, what would be your common denominator here? Cosine and sine. Yeah. So this guy is missing a sine.
And that guy is missing a cosine.
Yeah, got to squeeze the... Okay. And this guy's missing a cosine. So, got my denominator all set up, but can you tell me what's going on in this numerator here? And again, we're just looking on the inside here. Hold on. Hold on. Your brain's happening way too fast. Time out. That's not an eraser, guys. You're making me panic. Hold on, child.
It's squared, right?
Okay, so we got sine times sine, which is sine squared plus cosine squared. Hold on, brain. All right, now, Taylor, what is... Very good. She goes, now this trades out for Pythagorean. This is a Pythagorean trade. That's a 1.
Okay.
All right, guys, I feel like we're almost there.
I don't.
Now,
Agree to
cosine
disagree.
and that cosine cancel out.
Yes.
Multiplication and division.
Nice job. Daniel says, looky here, you got a multiplication question. Now you guys can go through and cross cancel.
And say cosecant of x.
And your brain worked too fast again. Look at that. All right. So it's 1 over sine, which, yes, Daniel, is cosecant of x. Oh, my goodness. That was a hoot. Wasn't that fun? Wasn't that magical that first hour decided to do that completely different how you guys did? And in the same number of atrocious steps, we still got to the same answer.
It's like
No,
we took
you're-
the elevator and they took the stairs.
No, you both took the elevator. That was the elevator.
What's not elevator? The stairs. What's the stairs?
Where are the stairs at? It would be difficult to climb the stairs on this question. It's just kind of, it needed a lot of work. It wasn't
It's
an
a ladder
obvious
and
one.
elevator.
So you don't ever want to go like and put a tangent in there.
Create a tangent?
Yes.
That would be difficult.
Well, like
I guess what some kids do is they start multiplying by things, thinking that they're allowed to do that. They're pulling a Daniel, if you will.
You can't just keep multiplying everything by 2.
You just keep multiplying things.
Why?
As long you can if it's a ratio, like 2 over 2. But if you just say like, I'm going to multiply everything by a tangent, that doesn't work.
A tangent over 1.
No, a tangent over tangent. He's just making stuff up now. I'm going to ignore him. All right. Oh, no. Oh, boy.
I need to see this.
Okay.
This is one of the ones that you want to cross out.
No, this is one where I'm just going to tell you now you're going to need a little bit of space.
There's no space.
You always need
Oh,
space.
actually, you know what? This one's not bad. I lied. This is not the bad one. 9's the bad one. Okay. We got this,
So
guys.
let's do this one as slow
No, we got
as
this. We got this. We got this. All right. You feel any instincts whatsoever here?
Given that
Multiply by
tangent.
2.
Multiply by 2. There is a 2 in this problem.
Do they cancel out?
What do you want to cancel? You tell me.
I would cancel the tangents.
Okay.
but
Okay.
I can't.
The only thing you can do right now, if you want to do some canceling, is you could take this denominator and you can separate this into 2 separate fractions as opposed to keeping it as 1. Would you like to do that?
Sure.
We can do that. All right. So we're breaking apart the common denominators if we do this. So you have tangent of x over cosecant tangent. This might be the stairs, but that's okay.
Oh, very sorry.
Oh, no. Taylor. That's okay. No one else was talking. Daniel's jibber-jabbering about 2s.
Seems like the easiest way.
There is a 2 in the answer. You're going to love it. Okay, so I like what Taylor's done here. The tangents will end up canceling each other out in that fraction, so that's kind of nice.
Nothing compared to how much now we have.
Well, okay, so I don't want to rewrite that the way it looks, because I'm really not happy with like anything in it besides this one sign. So can we start trading some things around?
Yeah,
So like sine I'll keep.
divide 1
Can
by
we call
sine.
secant 1 over cosine? And then this is one of those fractions within a fraction thing, so this will be fun. All right, cosecant is 1 over sine. Tangent is sine over cosine. That has promises right there. Okay. We'll leave this little guy alone for a minute. We'll come back and trade him in a moment. Talk to me about what's going on in this fraction. Do you see anything going on here? Like, what's this? The signs will cancel. So you've got this thing being divided by a 1 over cosine. I'm just going to do this. That was really naughty of me. I shouldn't do that. I should write it out, but I'm not going to. All right. How do you divide by fractions again?
You multiply by the reciprocal.
Right. Okay. So what I'm going to do now is... Can we trade 1 over cosecant?
Yes.
Thank you.
Can be sine.
It's sine. Very good. Yes. Reciprocals work that way too. So this is just a sine. So over here, y'all have a sine times a 1 over cosine times, and then you guys told me I was supposed to multiply by the reciprocal of this?
Yes. To get 1.
Aha. Look what just happened, guys.
And that is the Pythagorean. Right?
No, because this is sine plus sine.
Oh.
Daniel, it's your moment. Sine plus sine. 2 sine. We stole it from you. It was your one chance to say 2 and get it right.
Was that the stairs?
You know, not really. Kind of.
It was the dysfunctional elevator.
The elevator got stuck the other way too, so it's this was a difficult moment. But guys, if you step back and think about like the actual math manipulation we did, it was a lot of 5th grade math. It was like common denominator, not common denominator. It was reciprocal multiplication mixed with pre-calc. It was a hoot. Yes, Daniel.
Did you know that if you hold an elevator door open too long, it'll start screaming at you?
Yeah.
Did you find that out?
I learned that the other day.
Have you never been on an elevator before?
That was my first time holding the door open. For
Well,
someone.
8's actually real easy.
Okay.
Do you guys recognize it?
Yeah, you just put your foot in the door and it won't close.
These feel very Pythagorean to me. I'm going to leave the numerator alone for a moment. What's 1 plus tangent squared?
Oh.
It's secant squared. Very good. So I'm going to leave this guy alone for a moment.
You can't.
This is a Pythagorean trait. It's just secant squared. And that feels like something's going to happen. Something's going to reduce and cancel and make this prettier, right? Let's go back and trade these out for who they really are. Who is cosecant? 1 over sine. So this is really 1 over sine squared. And I'm dividing it by this guy, which is 1 over cosine squared. And then I go back to 5th grade and I remind myself how I divide by fractions. We flip this guy around and we multiply by his reciprocal.
Cosine of sine.
And what is cosine squared over sine squared?
Cotangent.
Cotangent squared. Cotangent squared. That one wasn't too bad, right? Again, that was the elevator version of getting there. There is a definite stairs way to get there, so I'm glad you didn't choose that one. I kind of forced you not to choose it. That's okay. All right. This one
So if
is...
you don't want us to choose the stairs way, though, what are we going to do when we accidentally choose the stairs way on the test?
It's okay, you'll get there.
Wait, is the last one cotangent squared?
Yeah, cotangent squared. Did you guys have an algebraic urge to distribute this? Just me? Okay. So
We're going to divide.
you're gonna need to start getting the urge to distribute, like for no reason, I guess, whatsoever. But while we're distributing, if you wouldn't mind, guys, I would like to call this a 1 over cosine. I would like to call this a sine over cosine. I would like to call this a 1 over sine.
And a 1 over 1.
And that's a 1, yes. Good job, Dean. Oops, my X got a little away from me. There we go. All right, so now when I multiply this together, we're running a little tight on time, so if you guys don't mind, I'm just going to kind of throw this together for you. All right, so 1 over cosine times 1 over sine is 1 over cosine sine. And then we got a plus 1 over cosine. And then this negative guy distributed in is going to end up being minus sine over cosine sine. don't cancel. Show you why in a minute. And then here, you got minus sine over cosine. Okay, here's what I'm seeing, guys. I'm seeing a fraction plus a fraction minus a fraction minus a fraction. 5th grade says what? I need a common denominator. What's going to be your common denominator here?
Cosine.
Cosine and sine. This guy has it. This guy has it. That's why I didn't want you to cancel that. And this guy is missing a sine. And this guy is missing a sine as well.
Ooh, boy.
So this is fun. Okay, so we got a 1 plus sine. Now we got a minus sine. I need a bigger vernaculum. And then a, what's the last guy
Minus
here?
sine squared.
Minus sine squared. Okay, something's got to happen here, guys.
Divide by sine.
Hold on, child. You can't do that. The sines cancel each other out. And y'all got a 1 minus sine squared up top. That's somebody. Who is 1 minus sine squared?
Cosine squared.
Yes, it is. So a Pythagorean trade for this guy gives you cosine squared. But you're dividing by a cosine and a sine,
So it's just cosine.
which means one of the cosines will cancel. And y'all got a cosine over sine, better known as cotangent, which is clearly the simplest answer.
Yeah.
All right,
I knew from the beginning,
real
so-
quick, because I do need this on my video, guys. This one, in 1,000 years, I don't think anyone would have thought to do this, so I'm just going to show you. Okay, first of all, this is the whole problem. There's a 1 in front. You'd have to trade this for his Pythagorean trade. I always forget this one. What is this guy? It'd be secant squared minus 1. And then you're going to factor it. And I'm going to tell you right now, the only reason I thought to factor this one, frankly, it's from experience, but look at his denominator. He's a factor of this guy. Isn't this just the difference of 2 squares? This is like if I asked you to factor x squared minus 4. You'd square root each of them and make one a plus and one a minus. So this guy factors into secant plus 1 and secant minus 1. Oops, I can't even write. I'm going to keep recording even though the bell's about to ring, because look what happens. So with these factors, the 1 plus secant, secant plus 1, those cancel. And you end up with 1 plus, there's no more multipliers or dividers, so I'm just going to write that green secant theta minus 1. And then children, 1 minus 1, those will cancel. Y'all get a secant. So this was a really tricky question where you had to do a Pythagorean trade, and then you had to know to factor. That was a very sneaky question. All right, you guys got page 317 for homework in addition to that one from last week.